Hey everyone, in this video what we're going to do is figure out what the limit is as x approaches infinity of sine of 1 over x plus cosine of 1 over x all raised to the power x. Let's begin by rewriting the limit in the following form. We have the limit as x approaches infinity of e raised to the natural logarithm of sine of 1 over x plus cosine of 1 over x all raised to x. Now, as the exponential function is continuous, we can actually move the limit inside the exponential function, and using the power rule for the natural logarithm, we can bring the power down to the front. Doing so, we have e raised to the limit as x approaches infinity of the natural logarithm of sine of 1 over x plus cosine of 1 over x multiplied by x. We can actually go a step further and rewrite this as e raised to the limit as x approaches infinity of the natural logarithm of sine of 1 over x plus cosine of 1 over x divided by 1 over x. Now, if we were to let x tend to infinity, in the numerator we would just have the natural logarithm of sine of 0 plus cosine of 0 as 1 over infinity is just equal to 0, and this is just equal to the natural logarithm of 1 as sine of 0 is 0 and cosine of 0 is 1, so we just have 0 in the numerator, and like I just said here, 1 over infinity is equal to 0, so we would also just have 0 in the denominator, so we have a limit of the form 0 over 0, and in order to evaluate it, what we can go ahead and do is use L'Hopital's rule. So let's do that. We have e raised to the limit as x approaches infinity. Now, in order to take the derivative of the numerator, we're going to have to use the chain rule. So we're going to take the derivative of the outside part and then multiply it by the derivative of the inside part. So the derivative of the natural logarithm is just 1 over its argument. And this is going to be multiplied by the derivative of the inside part. So in order to take the derivative of the inside part, we need to use the chain rule again. The derivative of sine of 1 over x is cosine of 1 over x multiplied by the derivative of the inside part, which is minus 1 over x squared. The derivative of cosine of 1 over x is minus sine of 1 over x multiplied by minus 1 over x squared. And of course, the derivative of the denominator is just minus 1 over x squared. Now, what we can go ahead and do is factor a minus 1 over x squared out of the numerator. Doing so, we have e raised to the limit as x approaches infinity of minus 1 over x squared multiplied by 1 over sine of 1 over x plus cosine of 1 over x multiplied by cosine of 1 over x minus sine of 1 over x. And this is all divided by minus 1 over x squared. Notice these two cancel, and we're just left with e raised to the limit as x approaches infinity of cosine of 1 over x minus sine of 1 over x divided by sine of 1 over x plus cosine of 1 over x. Now, if we just let x tend to infinity, we're left with e raised to cosine of 0 minus sine of 0 divided by sine of 0 plus cosine of 0, which is just equal to e raised to the first power. And that is the final answer to this problem. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe and check out some of my other videos, as it really does help the channel out. I hope you have a great day.